Bismillahirrahmanirrahim. What is data warehouse? It is an environment, not a product. So basically, a data warehouse is not a single software or hardware product that you can purchase to produce, provide strategic decisions. Basically, it is a computing environment where users can find strategic information with an environment where users are put directly in touch with the data they need to make better decisions. Basically, it is a user-centric environment. So let's summarize the characteristics of this new computing environment, which we call data warehouse. So it is an ideal environment for data analysis and decision support. It is flexible and interactive. User can interact with it. User can do point and click and perform the operations like drill down, roll up. It is 100% user driven. It is very responsive and conducive to the ask answer again ask again pattern. So the answer of a question leads to more questions, provides the ability to discover answers to complex, unpredictable questions. Data warehouse is a blend of many technologies. So the basic concept is it takes all data from different operational systems. If necessary, add relevant data from industry. That means the operational systems are not the only source of input to the data warehouse. Uh, from industry, the data can be added as well. Transform all data and bring into a uniform format. Integrate all data as a single entity and store data in a format supporting easy access for decision support. For that, create performance enhancing indices because now the data is huge. So to retrieve the from that huge data, the required information, you have to implement some techniques to get information quickly. So create performance enhancing indices, implement performance enhancement joins, and then we'll be able to run ad hoc queries with low selectivity. Means ad hoc queries in which there is no predefined pattern of queries. So it basically involves different functions. Data extraction, the function of loading the data, transforming the data, storing the data, and then providing user interfaces. So it is a blend of many technologies. You take data from the operational systems, uh, you perform extraction, cleaning, and aggregation on it, and you place it. Then after that, you load it into data warehouse, and which is used by executive managers and analysts. So it is a blend of technologies. Many technologies are used here. In fact, they all work together in a data warehouse. The end result is the creation of a new computing environment for the purpose of providing strategic information that every enterprise nowadays needs desperately. So, uh, to build data warehouse, different expertise are required. For example, data quality experts, data management experts, analyst, administrative staff, where various development tools are involved. So, uh, as a result of blend of many technologies, it is constructed. So the figure shows the inadequate attempts by IT to provide strategic information. This also shows you the difference between operational versus decision support system. This is a familiar merry-go-round for that comprises 4 to 6 weeks. So the fundamental reason for the inability to provide strategic information is that we have been trying all along to provide strategic information from operational systems. So if we follow this life cycle is used for operational systems, can be used for operational systems. If we follow the same life cycle to build a decision support system, we will not be successful. The operational systems such as order processing, inventory control, claim processing, patient billing are not designed to provide strategic information. If we need the ability to provide strategic information, we must get the information from different type of system. So only specially designed decision support systems can provide strategic information to you, not operational systems. So that means there must be difference in life cycle of operational as well as decision support system. So what is the classical software development life cycle? In this, first we do the requirement gathering, then analysis, then design, programming, testing, and integration. You are already familiar with it. While the decision support system does not follow the traditional development model. Here it is called data warehouse SDLC. This indicates that it is opposite to CLDS, SDLC. So in this first step is that you implement the warehouse by integrating data from multiple heterogeneous sources. So you test the data for biasness. That biasness means that there should not be only one type of information. For example, if there is a customer data, all customers should not be male customers or female customers, or all customers should not be in age above 80. So this in real time, this is not the case usually. So then you program with respect to data. You decide what algorithm you have to use depending on your data. In classical SDLC, you program with respect to requirements, but here you program with respect to data. Then you design decision support system. After that, you analyze the results, and then you understand the requirements. So how it is opposite? Here the requirements come at end, while in SDLC the requirements comes at the start. Basically, it combines operationals and historical data. So it don't do data entry into data warehouse. OLTP or ERP are the source systems. OLTP systems don't keep history, can't get balance statement more than a year. So data warehouse keeps historical data even of bygone customers. What is the reason? So data warehouse is different because again, it's not a database. You do data entry, in which you do data entry. As soon as there is some transaction occurred, the data is entered on the backend database. It's not the case in data warehouse. You are actually collecting data from different operational systems and loading into the data warehouse. So the transactional processing systems like the ERP systems, OLTP systems are the source systems for the data warehouse. You feed the data into data warehouse. So also data warehouse collects data over a period of time. After some time it again collects data, after some times it again collects data. So transactional processing OLTP systems, normally such systems don't keep very much history. So they don't keep history, don't keep the uh, very much history. So normally if a customer leaves the organization, the OLTP systems typically purged the data associated with that customer, and all the transactions of that customers they purge, you can say once a year. So once a year most businesses will purge the database of all the old customers and old transactions. So in data warehouse we save the historical data even of bygone customers, because you don't need historical data to do business today, but you need the historical data to understand patterns of business usage to do business tomorrow, such as why the customers left. In the context of bank wants to know why the customers are leaving. What were the events that led to her leaving? Why it is required? Because banks want, if the bank know the reason why customers are leaving it, then he can adapt a strategy to retain the customers. Because if customers are continuously leaving the bank can lose the business. The question is how much history you keep in data warehouse. It depends on various factors such as industry, cost of storing historical data, and economic value of historical data. So this means that how much we historical data we place in the data warehouse, it vary from industry to industry. So so how much industry depends on industry as well. So in telecommunication industry, typically around 18 months of data is stored, because there are a lot more call details records than there are bank transactions, deposits and withdrawals. So the storage period is less as compared to bank. So further, another point is if we go further back in history you store the data, the less value it has normally. So usually if we move very much back in history, uh, that you are not getting the most predictive data. So again, it varies from industry to industry. So for re retailers, retail industry usually keep 65 weeks for data for analyzing for the analysis. In an insurance industry, you keep 7 years or 10 years or 15 years of data, because insurance industry is of a type that if you want to make predictions in that, you have to keep uh, um, many years of data in it. So how much history you keep in the warehouse, it depends upon industry. cost of storing historical data, how much cost you require to store the historical data, and how much economic value you are retrieving as a result of cost. So if you are spending cost to store 10 years of data and you are not getting that economic value from that, so then you have to make decision whether to bear the cost or not. So these are the factors. How is it different? Usually, but not always, periodic or batch update is occurred in data warehouse rather than real-time update. But for an ATM, if update not real-time, then lot of real trouble will be there. So data warehouse is strategic for strategic decision making based on historical data. Won't hurt if transactions of last 1 hour are absent. So think about ATM system. When we put ATM card and make a withdrawal, the transactions are happening in real time, because if they don't, the bank can get into trouble. You can withdraw more money than that than had in your account. So the records are updated, deleted, and inserted in real time as the business events takes place, as the data entry takes place in operational or OLTP systems. Because if update not real time, then lot of real trouble. But in traditional data warehouse, that's not true. Because for strategic decision making, because data warehouse is for strategic decision making, not for running day-to-day business. And for strategic decision making, I don't need maybe I don't need last 10 minutes or last 1 hour data to make strategic decisions. Strategic decisions take the long-term perspective. So for this reason and for efficiency reasons, normally what happens is that in the data warehouse, we update on some predefined schedule basis. Maybe we update once in a month, maybe once in a week, or maybe it's even once every night. So again, rate of update depends on volume of data, nature of business, cost of keeping historical data, and benefit of keeping historical data. So again, it depends for which industry you are um, making the data warehouse. So it varies from industry to industry. So for insurance industry, usually you can update after a month. It won't hurt, I think. So and how cost of keeping historical data, because you have to bear cost to keep the long term historical data. If you go more back in the history and you want to save uh, lots of your data in the data warehouse, you have to bear extra cost for that. So you have to analyze these two aspects, that the cost you are bearing, whether you are getting the benefit from that cost or not. If your benefit is more, then you will bear the cost. So this is the end for today's lecture. Summary of today lecture. We have discussed in this week the various definition of data warehouse. We have discussed the reason why data warehouse is required, how it is different from traditional systems, how it is basically it is a blend of many technologies. We discuss the life cycle of data warehouse. So we discussed the various queries in it. Okay, how there is a difference in queries between traditional database management systems and intelligent enterprises. And then we discussed that how much history we should keep in the data warehouse. Again, it depends on various factors.